Hello everyone, welcome to BERT and today in this session we'll see the implementation part of the AutoTokenizer and we'll see how what are the different types of AutoTokenizers, what are the different functions available in it and how we could use as per to our personalized task. So let's start. First of all, we'll see the main component, that is the pipeline, which is present in the uh, transformer library, through which we can create a or we can use the pre-trained model for our inference. So first we will start with the definition of pipeline. So it is used to or it is used for pre-trained models. Just I can mention, it is a way to use pre-trained model for inference. Now for inference is just prediction on our prediction on our own data. And it generally or it abstract that most of steps needed to make inference. Now we'll start what are the different tasks available in the pipeline. So you see the task list from transformer dot pipeline import pipeline registry and pipeline registry dot supported task and view. Now we'll see the different task list is available for us. Suppose if you want audio classification, text to audio, text classification, question answering. So multiple tasks are available. We'll see. But generally, when we select the task, we don't need to add any multiple steps, and model is directly available as a pre-trained model, and we can just ask the questions to the model, and it will answer. We can also use for summarization, translation. For from transformer import pipeline available task equal to pipeline dot supported task bank available task dot e. So these are the different tabs available. Now we'll see how to use pipeline. Next is how to use pipeline. So from transformer import pipeline. And suppose I want sentiment classifier and pipeline. I'll mention the task, that is the sentiment analysis. Okay. Now when I print it, print sentiment classifier. So you got the name, that is the text classification pipeline. From transformer.pipelines, we have got text classification and text classification pipeline. Now, if I pass an input towards the model, suppose I want to analyze the mention the first sentiment classifier, and I will mention the example. Suppose this is a good painting. I want to save the label basically, so it shows it is positive as good is present. So we got the sentiment of the example as positive. Now you can use a specific model. So using specific model, or suppose I make a sentiment classifier, and I'll mention pipeline. I'll mention the task. I want sentiment analysis. Okay. And then I'll mention the model name here. I'll mention the distill BERT. Okay. BERT date indicate. Okay. So in this way we can download any model we want. Now what are the important parameters we can pass here while using the pipeline? Important parameters. First of all is the task. You should mention the task name, whatever the task you want sentiment analysis, summarization. So that will be the task. Next would be the model. So in model, we need to mention the model name, right? Then is the model, which will be in the dictionary format, and then these are the model specific arguments. Next is device and device map, which are used for utilizing CPU or GPU. Okay. These are the important parameters we pass during the we are defining any model here. So we can pass the task model, then the device map, like etc. Okay. Now next we will see what is pipeline made of. Okay. Next is what is pipeline made of. First one is tokenizer. So what is the use of tokenizer? To convert textual data into format expected by model. To convert textual data into format expected by model. Okay. Next is the model. So it is used to make prediction from whatever the input we pass, right? That is the use of model. And then is the post processing. So from model output to human understandable format. Okay. Now this all three steps are covered in the pipeline. There is the tokenizer, model, and post processing. Just if you use pipeline, and just mention the model name, and we can get the all three steps in one go, and we can get the inference of the model. First of all, we'll see the tokenizer. As we have seen, it is used to convert textual data into format expected by model. So, we'll first of all import it from transformer encode AutoTokenizer. Okay. Then say tokenizer equal to AutoTokenizer from pre-trained, and I have mentioned the model name. Suppose bird, date, and cake. The tokenizer has been downloaded. Now, what if I want to save this tokenizer? So, what I'll do, tokenizer dot save pre-trained, and I will mention the name. So, I'll say bird tokenizer, bird token ID. And when I save it, so after some time, if you want to use again, so we don't need to download it. We just need to copy the path and mention the path there. The tokenizer can be imported from the path directory. And for loading the tokenizer which we have saved, would be save tokenizer equal to auto tokenizer from retrain, and I will just mention the path here. I will copy the path and I will paste it. So we got the tokenizer. Now I will mention the model name. Model equal to suppose distal bar, which we had used earlier. Distal bar, distal bar, right? And Dave and Ankit. Okay. And I'll mention tokenizer, auto tokenizer from pre-trained, and I'll just mention model. That is this one. When I run this cell, I got the tokenizer. Suppose I want to tokenize a particular sentence. What I'll do, I'll use the tokenizer and I'll pass the sentence here. Suppose this this is a great layer. Okay. So this is my sentence and I want to tokenize. When I pass it, run this cell, you will see encoded dot input ID. So we got 101. Now we see here, we have how many words? 1, 2, 3, 4, and 5. And how many values we got here? Encoded values 1, 2, 3, 4, 5, 6, and 7. So two values have been added here, right? Now we will see what are the two values. Tokenizer dot convert ID to token, and we'll mention encoded dot input ID. So KLS is the start of the sequence, and generally ASCP is the last part of the end of the sequence. And we denote by for the BERT tokenizer what we have. We have 101 value for the start, and for the end we have 102. Okay. Now suppose I will mention some different value. I want to see what these values represent. Tokenizer dot convert ID to token, and I will mention different numbers. Suppose I mention 0. Okay, then I mention 100, then we saw the 101, so I'll mention 101, 102, and 103. When I run this, so for padding we have 0, for unknown tokens we have 100, for start we have the 101, for end we have 102, and for mask tokens we have 103. So these are the special tokens which are used. Now we'll see what are these tokens. First of all, the will be special token. So pad is just for padding. Then we have which is the unknown tokens, or we can say out of vocabulary. Okay. Then we have the CLS, which is the start of the sequence. Start of the sequence. Then we have FTP, that is the end of the sequence, end of the sequence. And then we have the mask, that is the masking. Okay, these are the special type of tokens used. Now we will pass the list here and we'll see how it works. Suppose I pass the list here, text list. I mentioned this is a great movie. Okay, the great movie. Yeah. Then I pass another one. So this is not a good person. Okay, and last will pass. This is not, or this is very ugly. Okay, now I want to pass this to my tokenizers and we'll see what output we get. So I'll mention encoded equal to tokenizer. I'll mention the tokenizer. I'll pass the list, that is the text list, and I'll mention padding equal to true. Okay, I will see how it looks for I encoded dot input ID is print tokenizer dot convert ID to token, and I'll mention the I. And I run this. So for the first sentence, this is a great movie. First we start with the start of the sequence. This is a great movie, and then will be the end of sequence, and as it is not equal to the size of the most largest sentence, that is not a good person. So one token will be here padding the one token will be the padding one. For the second sentence, that is this is not a good person. We have the start of the sequence. This is not a good person, and then we have the end of the sequence. For third sentence, this is very ugly. Start of the sequence, this is very ugly. Two tokens are remaining as compared to the largest one. So we will have the two padding tokens here. So in this way, we have seen the BERT tokenizer. The Now we'll see how many values we have. So encoded. So we know 101 start for start of sequence, then 102 for end of sequence, and 0 is for padding. Okay. So this is for the first sentence. That is, this is a great movie. This is a great movie. Okay. Now next is what second sentence. This is not a good person. Start of sequence 101. For this we have 2023. For ease we have 2003. And then we have the end of sequence of 102. And we have the third. You have 00 for padding here, 102 for end of sequence, 101 for start of sequence. For ugly, you have token 9200. And we have the attention mark here. So attention mark is not working for the pilot token, and we can see we have one pilot token at the last. So for that value, we have 0. And for the third sentence, we have two pilot tokens, and we can see two pilot tokens. So attention mark for the two pilot tokens is 0. Now we see the BERT tokenizer. Now we'll see the Albert tokenizer. How it works. Albert one. Albert. Date E. I'll mention it as Albert tokenizer. Albert tokenizer. I'll mention AutoTokenizer from pre-train. And I'll mention the model name. That is the Albert A and read. I will pass input and see how the Albert tokenizer works. So Albert tokenizer, and I'll pass to the go play outside. Okay, is my first. Second is uh, do not make noise. Not make noise. Okay, so these are the two, and I'll pass it. Now, as you can see, the Albert tokenizer is working different. So for the first one, that is go play outside and do not make noise. We have different types here. We have token type ID which was not present previously in the BERT one. Attention mask was available. And in case the input IDs, you can see different numbers here for the start of the sequence and the end of the sequence too. So we'll see. So here input ID is are just the index of each token. Index of each token. In index of each token in vocab. Okay. Next is attention mark. Attention mark. We show whether to calculate attention for this token. Okay. And then we have the token type ID. Right. We have token type ID, which tells us the sequence number. Okay. The sequence number or the sentence pair. We can sentence pair. As you can see here, we have 000 for the first sentence, and for the second sentence we have 1111. Now we will take a text. Where are you going? Okay. This is my sentence, and first of all I will see the encoder, which has a BERT encoder, and I will try to tokenize it. So tokenizer, and I will pass the text. And this is the BERT one. Remember, this is the BERT tokenizer. BERT tokenizer. This is a BERT tokenizer. And when I mention the encoder, so we got the input ID. What are the input ID? Index of each token in SEP. These are the special tokens 101, 101 and 102. These are the start of sequence and the end of sequence. And these are the index of each token in vocab. So where has index 2073 in our vocab? R has 2024 as index number in our vocab. Attention mask is whether to calculate attention for this token. I will say again, tokenizer dot convert ID to tokens, and I will pass the encoder dot input ID. Okay, you'll get to see start of sequence is 101 and 102 is end of sequence. I hope you guys are understanding. Now same for this text, we'll see how the Albert tokenizer works. Okay, I'll done Albert encoder. Yeah, the Albert tokenizer, and I'll pass the text. Okay, Albert. I will see how it looks. Albert encoder. We got the input IDs, that is the index of each token in vocab, then token type IDs, where is the sentence where, as we have only one sentence, that is the text where are you going, so only we have one. Then we have the attention mark, so to calculate the receipt or whether to calculate attention for this token or not. So we got this for Albert tokenizer. Now we'll also convert these IDs to token. So Albert tokenizer convert ID to tokens, as mentioned the Albert encoder dot input ID. Input ID. So 2 we have for the start of sequence, 3 we have for the end of sequence, and these are the tokens, that is where are you going. So in this way, the Albert tokenizer works. Now we have seen the two types of tokenizer. One, we have seen the BERT tokenizer, how it works. We have seen the Albert tokenizer. Now we'll discuss the parameter while defining a tokenizer. So parameter while defining tokenizer. So while defining tokenizer, I mean when we are mentioning like tokenizer is equal to, we say, auto tokenizer and from pre-trained, right? And here I pass the model name. So I suppose I say model. So during this time, what are the parameters we can mention or define here? So first of all is the model name, right? You can mention the model name, then or else you can mention the path. First is that one. Okay. Then second is use path, use path. By default, it is true. By default, it is true. And what it is used for? It loads faster version of tokenizer. Of tokenizer. Next, we have use authorization token. That is the Hugging Face key. Hugging Face key. So if auto tokenizer is not field available, we need to get the key from Hugging Face. So in that for that for this special type of auto tokenizer, we need to mention the key here, which we get from Hugging Face, and we need to mention the parameter use authorization token. Next is do lowercase. Do lowercase. By default, it is false. And what it is used for? It is used to convert to lower, convert to lowercase. Okay. Now this is used to mention the name of the directory folder. Folder. Where tokenizer file should be there. Tokenizer file should be stored. Okay. These are the parameters while defining the tokenizer. Now next we will see parameters when tokenizer is called. Next is parameter when tokenizer is called. So when is this part? So when we mention tokenizer and I mention the text. So what are the parameters we can fill here while passing the text? First one is the text. You know that we have seen it. We have seen earlier. So first one is the text. We have also seen one time we had did the padding. So what is padding? Now by default it is false. It is false. Okay. Now if it is true, so what will happen? All sequences are padded to the longest sequence present in the text in the or to the longest sequence present. Okay. Now we have seen earlier. So yeah. So in this example, as padding is false, we mentioned here true, right? By default it is false. We mentioned true here. Now what happened? Which is the longest sequence here? So among three, this is not a good person. So this is the longest sequence. So we get all sequences are padded. That means the first and third was padded according to the longest sequence. So how many letters are there? Tokens are there? 1, 2, 3, 4, 5, 6. So 6 tokens here are considered. Now here only 5 tokens are there. So last one will be added and that is the padding token. Here only 4 are available. So longest is 6 tokens. So 2 padding tokens are added here. As you can see here. For the third we added 2 tokens to complete the 6. And for the first we had only 5. So we added 1 token. So that is the padding. So all sequences are padded to the longest sequence. And if I mention false, so no padding. Right. No padding will be done. Will be done. Now, if I mention here longest, it is same as true. And next is so if I mention longest or if I mention true, it is same. No change in that. If I mention max length, that is a fixed length. So we'll mention the length of the tokens to be there for each sequence. So that will be fixed length, and to fixed length, all sequences will be of the according to the fixed length or sequences will be same as fixed length. Okay. Then third one will be the truncation. In case of padding, we add tokens, right? But in case of truncation, we remove tokens. Generally, we do padding. We avoid the truncation to retain the meaning of the sequence here. So generally, try to avoid truncation. For one is return tensor. By default, it is none. By default, it is none. That is the Python list. But if I mention here as PT, it will return PyTorch tensor. If I mention TF, it will return TensorFlow tensor. And if I mention NP, it will return numpty array. So these are the parameters you can pass when tokenizer is called, and these are the parameters for defining tokenizer. Hope you guys understood, and you can guys practice different examples by using different sentences or sequences. Now for the TensorFlow, whatever I'll do, I'll see how it works. Previously, when we were using, so this was the Python list. We are not mentioning here, right? We are not mentioning the return tensor. Oh, I'll mention tokenizer, not sorry, I'll pass the sentence here. Is a good one. And I'll mention return tensor. Suppose I mention PT. Then what will happen? Okay. Now it is tensor here. This is for flow. I'll mention here TF. So for pointers we got tensor, and for TensorFlow we got TF dot tensor. Now we will see for numpty array. Okay, we're getting array. What if I am not mentioning anything? We are getting a Python list. This is for Python list, for this for numpty array, this for TensorFlow, and this for Python. Okay. So I hope you guys understood the AutoTokenizer part here, and you guys could practice more examples to understand and see the implementation part of it. And we'll see you in the next session with the new topic. Till then, bye.